Cool. I think that's worked. Hopefully. I'll have to give it a sec to find out.
Okay.
Oh, okay. I think we're good. Hello, everyone. I'm joined by Alex Warnes, who is here to teach us about Threlte, which I've used before, and I've been following their development for a while, and I love it. I haven't done too much 3D, so I'm hoping to learn a lot from this. But I'm really excited. Do you want to introduce yourself?
Sure. Thank you so much for setting this up. My name is Alex Warnes. I'm a front-end developer for SecureWorks, and I've been coding for about 5 or so years, maybe 4 years. And hey, everybody, I'm just seeing the chat now. So earlier this year in 2022, I finally wanted to try to learn Three.js and kind of started that process in January. And Svelte Cubed had just come out kind of late in 2021. And so I started to work with that, and then eventually needed a little more capability. And so started using Threlte, and I've just loved it. So as a beginner to Three.js, I think it's a great tool. And I think seeing what people are making with it and getting help from the Discord channel, it's clear that as advanced Three.js users also are really doing some amazing things with it. So I think just as a beginner to 3D, I was really excited to find a tool that could allow me to use Three.js in a way that it really hadn't clicked for me before. Trying to do the plain Three.js style of coding was quite challenging. It felt like there was a checklist of 100 things to do anytime you wanted to set something up, and Threlte has really helped me to check those boxes. It takes that list of 100 down to maybe four things that you need to do, and then you can just be creative and make whatever you want. So it's been a really fun process, and I'm excited to share it with everyone and answer whatever questions I can.
That's really awesome. It's nice to hear that you haven't been in it that long. I think it really shows to how powerful these tools that we're building are, and what we can achieve with them, even in small time.
Yeah, definitely. And I know everyone's process is different, but for me, I tried to learn Three.js before, and like I said, it just never really clicked. And then I did discover Three.js, which is a free online book to get introduced to plain 3. And I did that alongside learning at the time Svelte Cubed, and it was a really helpful process to see the imperative vanilla Three.js code and then see a declarative version of it next to it. And you really appreciate what a declarative framework can give you versus plain Three.js. So I know some people like writing the regular Three.js style, but for me, it was much easier to do with a declarative style. And Threlte took, I think, what Svelte Cubed had and just just knocked it out of the park. It's really there's so many resources available to build your Threlte scenes, and it has so much built into it, from physics to interactivity and great documentation, that I think it's just such a fun tool to use.
Yeah, I definitely agree with you with the declarative thing, especially with how Svelte is reactive first, and everything from what I've tried in Threlte, it just works perfectly out of the box. It's been really fun to build with it, and it's good that you mentioned the physics as well, because it's not just declarative 3, it comes with extra things. Like, I dread to think how long I would have had to search for how to do physics in 3 without it just being there for me in like a couple of components. It's great.
Yeah, absolutely. And sometimes I look at the source code for Threlte for things like the physics integration, and I think, I don't know if I ever would have gotten this far. There's some brilliant minds behind the source code there, and it's also a great repository to start contributing to, because it is still relatively new. Threlte started this year, and So if you're looking to make contributions or just a community to get involved with, it's been great. And like you said too, that I want to highlight, it works really well with Svelte. So if you're new to Svelte, or even if you're not, there's so many things that come from Svelte, like tween stores or easing functions, the reactivity, that if you work well in that sort of model, Svelte's model, integrating Three.js and getting these things to work just clicks. It's really, really fun. And it's pretty amazing how quickly you just kind of are able to put things together that you think might be more challenging than they are.
That's really awesome. I will, after the stream, I'll put all the links to everything, like the Threlte Discord and the website, in the description of the stream, for anyone wanting to check it out. But let's go ahead and we've got a pre-recorded video that Alex has put together for us to show us a bit about Threlte. So yeah, and then afterwards we'll do a Q&A.
Sounds good.
Awesome. Bear with me.
Using Threlte. Threlte is a really cool library that I used as I started to learn Three.js and how to do 3D in the browser. And it makes it really easy with some basic building blocks to get started with making these 3D scenes. It includes things like interactivity and physics and other really useful helpers out of the box. And that enables you to start building with basic patterns and basic components and incrementally adopt more advanced techniques. So let's get started on our first scene. We'll open up a new tab and type in sveltekit.new, and that'll create a new blank SvelteKit project for us on StackBlitz. I'm going to take a minute to get rid of all the default stuff in here, and then we will start with setting up our Threlte app. So after a bunch of deleting and a few refreshes, we're good to go with our new SvelteKit app, our new blank SvelteKit app. So let's stop and we'll switch over to the Threlte docs. So you can see here on the Threlte getting started, there are 3 steps: install Threlte core, Threlte extras, and 3, which is Three.js itself. And then if you want TypeScript, you can install the Three.js types and adapt our Vite configuration. So we'll scroll up to step 1 and we will copy this, switch back to our application and install Threlte core, Threlte extras, and 3. And so Threlte has 3 main packages. There's core, which is all of the sort of main components that you use to build a 3D scene. And then there's extras, which includes some really helpful additional components. And you can see here in the documentation, everything from core is here: lights, cameras, controls, some miscellaneous things, and some primitives as well, and some hooks to have access to a lot of the context that you have in your scene. Down here in extras, you can see some additional hooks for things like animations and cursor interactions, some extra components, which are sort of quality of life improvements, things that would require a lot of boilerplate to set up that Threlte just gives you out of the box in this extras package. And then the third package is Threlte Rapier. And this is the physics that comes with Threlte that we're not going to cover here, but it's really straightforward. You can check out these docs. Hopefully, once you watch this and you make a couple scenes with some basic meshes, you'll feel comfortable jumping into the documentation for the physics as well and see how easy it is. So we just did step 1, and now we'll skip TypeScript for this, and then we'll grab this Vite configuration and flip back to our application, go to Vite, drop it in here, hit save, and then don't forget to serve our app. And we deleted everything, so there's nothing to see. Now we are ready to set up the scene. So what we're going to do is just in this root page component, we're going to make a couple scenes and we'll go through the basics in each scene. And hopefully that'll give you a solid foundation to sort of build off of as you experiment and try out different components on your own. Let's take a quick look at what goes into making a Threlte scene. To set up your scene, you'll always want to have 2 things and then 2 more things that are technically optional, but you'll probably also want them. Number 1 is a canvas wrapper. And this is just an HTML element, like a div or whatever, that is explicitly positioned, and the canvas will always fill up this HTML element. And so this allows you to incorporate your 3D scene, the canvas, into your layout however you need to, whether that's grid or flex, or you want it as the background of a header, or whatever you want to do, You just have to worry about handling it with this wrapper. Number 2 is the canvas, and that's a component that Threlte gives you that manages all the context for your scene. Number 3 is a camera. Like I said, it's technically optional because there's one that would exist by default, but you'll almost always want to change something about the camera. So we'll bring in a camera. Number 4 is light. Again, you can sometimes do stuff without light, but in most cases you'll want to include light. So I include those 4 things. That's the 4 steps that I always take whenever I set up a scene. So back in our page component, let's go ahead and in our script tag, we'll import canvas from Threlte core. Okay, so for scene 1, we want to have a wrapper around our canvas, div called canvas wrapper. And then inside of that, we want a canvas. And that's our Threlte component. And then here's where we will drop in our scene 1 component that will contain everything for our scene. And then remember, this canvas wrapper has to be positioned so that the canvas can latch onto it, which means we have to give it a positioning of relative or absolute or fixed or whatever it is that we need it to have. And in our case, we're just going to use relative so that it can just have the normal DOM flow for this element. And we also gave it a border so we can see it a little easier. Let's hit refresh. There we go. Now you can see that's where our canvas currently is, but there's nothing in our scene. But this allows you to see sort of where that is. And whatever we do to our canvas wrapper, if we say, height 500 pixels and hit save, you can see it adjusts that, and it will also adjust the canvas along with it. So let's go ahead and create our scene 1 component, and then we'll import it into this page so we can start looking at our scene. So we've got our wrapper, we've got our canvas, and now we want to have a camera and some lights. So we'll go ahead and set up a script tag. We'll import from Threlte core a perspective camera, and there are a couple different camera types, but we'll use perspective. And directional light and ambient light. So down here in our template, let's just use our camera. We'll drop that in, and you can see that has a position property and a look at property, and we'll cover those in a little bit more detail as we get some stuff in our scene so we can see what we're dealing with. And then we want to bring in the directional light and the ambient light. So now let's go ahead and add our first mesh. We'll use a mesh component from Threlte core, and a mesh is a geometry plus a material. And a geometry is essentially just the shape of an object, and a material is what the surface of that shape should look like. And so down here where we add our mesh, it's going to take 2 properties, geometry and material. So the geometry and material are going to be from Threejs itself. So let's go ahead and import a mesh standard material and icosahedron geometry. And if we flip over to the Threejs documentation here, you can look for geometry, and you can see that there's a bunch of different geometries you can choose from. And on the Threejs site in the docs, you can adjust all the different configuration options. For our material, we're going to use a mesh standard material. And again, you can just look for materials, and you can see there's a bunch of different materials here, and they all have different properties and different ways of interacting with light and different ways you can make those surfaces look. So we'll stick with this for now. This is a pretty basic approach to just use the mesh standard material and a geometry. Down here in geometry, we will say, I don't want to type all this out. We'll say new geometry and instantiate it like that. And then for our material, same thing, new material, go like that. And then this accepts an options object here, and we're just going to add in a color, and let's say, and this will take any hex string that you give it. Let's do a quick refresh. Oh, It also helps if you import your scene into your actual canvas. So over here where we have scene 1, let's go ahead and import our component. There we go. Now we can see it. And let's just make our canvas a little bit taller. Now back in our scene, we can take a look at some of what we've done. So let's start with the camera and this position property here where we have a Y and a Z value. So while working in 3 dimensions, positions are defined by their position on the X, Y, and Z axis. By default, objects are placed in the center of the scene at 0, 0, 0, which is right here. So looking at our code, you can see that our camera is positioned Y5, so up just a little bit from 0, 0, 0, and Z10, which means sort of toward you, toward the screen, by 10 units. And whatever values with Threlte, whatever values you don't specify in these properties are assumed to be their default value, which is 0. So with the look at, we are taking our camera and we're telling it where to point. And so in this case, we're telling it to point at Y0, we'll say X0, Y0, and Z0. And that's helpful just so we can be very explicit about where the camera is looking. And you can see if we change this, the camera just looked up. And so now our mesh is obviously slightly less visible. So we'll say Y0. And this position property exists on almost everything. So our mesh itself has a position property, and we've just moved it right to where our camera is so we can't see it. So let's go ahead and get rid of the Y and get rid of the Z, and it'll go back to its initial position. And we can move it over 3 or over 2 or whichever way we want to go. With Threlte, all of our component properties are reactive, which means whenever they change, our scene will automatically update. And we just saw that when we move our mesh over 3 and then the other way 2, it kind of goes back and forth to both of those positions. That's pretty straightforward. But this is where Svelte's built-in tween stores and easing functions can help us create smooth motion on demand. First, we'll import tween from Svelte motion, and then let's create a variable t. So if you haven't used them much, a tween store is just a store that transitions from one value to another over a specified duration. So we've given it a default value of 3, and then if we update this store, if we say, set t to 5, the value of t is going to change from 3 to 5 over the course of whatever duration we give it, in this case 2 seconds. And so down here, we can use the standard Svelte auto subscribe to get the value out of our tween store. And then just for the sake of example, let's see what this looks like. You can see that it goes from 3 to -3 over the course of 2 seconds, and it does so smoothly because that t value is changing to all the values in between the two that we've set. So let's get rid of that before we forget and use interactivity to trigger the movement. So let's say we want to click on the mesh, and whenever we click on it, we want it to move back and forth. If we look at the Threlte docs and we go down to mesh, you can scroll down and you can see properties. So for anything in the documentation here, it'll have properties that you can look at and tells you what the default value is and what the type is. It has bindings if you need to bind specifically to the class of the thing that you're on. And then events that are emitted from the component itself. And so for these, if we want access to these on a mesh, we want to use this interactive property. So we'll go back to our scene, and down on our mesh, let's just say interactive. We can access our onClick, and we can say t equals, if t is greater than 0, we want to set t equal to -3. Otherwise, we want to set it equal to 3. Helps if you include your ternary operator. So now in our scene, if we click, you can see that value's been set to -3, or it's been set to 3. And what's really cool is that we can use this on any property on the mesh. So let's just say we wanted it on the scale property. We can scale from 3 to -3, or the rotation property where we specify an axis of rotation. Let's just say Y. And when we click, we can see that we're now rotating and moving at the same time, which is really cool. And since all of our mesh properties are dynamic, you can add more stores with custom durations and easing functions, or chain your animations, or move other objects like the lights or the camera around, all at the same time. So far, our animations have been on demand. It starts when the value changes, and it stops when the value stops changing. If we want to run a constant animation, what we need is for some value to update on every frame. And for that, Threlte gives us a hook called useFrame. So we'll import useFrame from core. And then down here, we can say useFrame. And this just takes a callback function, and it'll execute whatever's in here on every frame. So let's create a new variable here called R, and we'll set that equal to 0. And down here in our mesh rotation, let's get rid of these and just set the rotation on the, let's say, the y-axis to R. And by default, your rotations are all at 0. And now on every frame, let's say R equals, look at that. So now R is changing on every frame, and we get this constant animation in addition to our on-demand animation. And we've got some interactivity. And one thing to keep in mind is that these hooks that we get from Threlte, like useFrame, rely on the context of our scene. And so they have to be used inside of our canvas component, which for us is not a big deal because we've wrapped our whole scene in the canvas component. But sometimes you might be rushing or whatever, and you'll have, let's say on this page, if we wanted to say use frame and we've got a mesh in here, it would throw an error because our use frame in the script tag here would not have access to the canvas context. So now our first scene is complete. We have an interactive mesh. We used a Svelte tween store that enables smooth motion between two values. And we have the use frame hook that continuously spins the mesh on every frame. So for our second scene, we're going to import a model. If you want to drop a 3D model into the scene, Threlte has a component to make that process really easy. So let's set up our scene with a canvas wrapper and canvas, and then make a new scene2 component. Okay, so in scene2, in our script tag, we want to bring in all of the same things we brought in before. And then we're going to use Threlte extras to bring in the GLTF component. So let's set up our scene. All right, so GLTF, these are models that you might find on Sketchfab or you'll make in Blender, and it's a file extension that's very common for 3D models. And so this component accepts a URL property that is the path or the URL to wherever your model is. And so we're just going to make a string up here. And so we can just say URL, and you can see a very tiny shoe over here. Maybe you can see it, maybe you can't. So let's make that bigger with the scale property, and we'll set the scale to, I don't know, maybe 20. That looks good. So you can see we've got a shoe here. Now, it would be nice if we could move around our scene to see sort of all around the shoe and get an idea of where things are positioned. And that's something called orbit controls. And that's another component that comes out of Threlte core. You just have to make it a child of your camera. And then this gives you the ability to rotate, to pan, to zoom in and out. And it's just that component dropped in. And there are a bunch of properties you can use, like auto rotate, where it'll give you some default behavior of those controls. And the GLTF component takes all the properties you'd expect, like position, rotation, and scale, plus some specialized props for different loaders like use Draco or KTX transcoder path. And those words all sound cool, but we don't need to worry about that for our model. And that's really all it takes to load a GLTF model with Threlte. If you need more advanced control for something like animations, you can load your model with the use GLTF hook and then access whatever model properties you need on the GLTF that's loaded from there. Now, the only thing cooler than a shoe is a shoe that floats. So let's import the float component from Threlte extras. And this component was ported from a component by the same name in the React 3-fiber ecosystem. So I do want to say thank you to all those authors and contributors and maintainers. They put out a lot of amazing scenes that I've learned a ton from digging through that code. So thank you to all of them. And simply put, this component makes its contents float. And there are some optional properties that factor into the floating effect. So let's see what that looks like. We just want to wrap whatever we want floating in the float component. In this case, we want our shoe to float. And you can see, let me turn off the auto rotate so we can see it a little bit easier. So you can see float gives it a little bit of an effect just by default. And we want to step up some of that intensity a little bit. So let's use the rotation intensity and set that to 5. There we go. But we're still missing a little bit of perspective. It would be nice if we had some way of knowing sort of where it's floating. So let's add a mesh underneath, sort of like a floor, and then we'll add some shadows too so we can see it moving around a little better. So we learned how to add a mesh in the first scene. So we'll import the mesh component from Threlte core, and then we'll import mesh standard material from 3, and let's just say a box geometry from 3 as well. And then down here, we'll use our mesh. For the geometry, we'll say new box geometry. And for the material, all right. And if we move, we can see there's a box right in the center of the scene at position 0, 0, 0. And we want to move it down just a little bit. So down is on the y-axis, so we'll say y, let's say -2, and now we can see it's moved down. We want it to look a little more like a floor, so let's adjust the scale. And scale, you can adjust all of the dimensions at once. If you just pass a single value, let's say 5, you can see now we've got a 5 by 5 cube, or you can do it by individual axis value, which is what we're going to do. So let's say x, which is from our orientation is left and right, we'll say 10, y, we'll say 0.5, and z will also say 10. And so now we've got a little bit more of a floor that you can see here. And the next thing we're going to do is move our directional light. So right now the directional light is at 0, 0, 0, and we're getting the directional light. You can see that one side of the shoe is brighter than the other. But we want to make sure that we cast our shadow down here onto the floor. So we're going to move the light up a little bit. So now you can see that it's brighter kind of coming from up here and darker down in this side. And that's what we want. So hopefully we'll get the shadow down here. To create shadows, there are 3 things to remember: create, cast, and receive. So we're going to specify which light or lights we want to create the shadow by giving them a shadow property, which is the equivalent of setting shadow to true. And then what do we want to cast the shadow? In this case, we want our GLTF to cast the shadow. So we'll say cast shadow. And then we want our box geometry to receive the shadow. So we'll say receive shadow. And just like that, you can see our shadow pops right up, and you can see it moving along with the shoe. And that's pretty cool. All right, we've learned some of the basics with our orbit controls, bringing in a model into our scene, casting shadows, receiving shadows, on-demand animations that we triggered with our on-click event, and interactivity that gives us access to all those different events on the mesh, and constant animation using the useFrame hook. Now let's talk about a couple other things that will help you when you're building scenes. In our scene 1, you might remember as we were trying to adjust the rotation or the position, it was kind of hard to tell where we were. Well, Three.js has a bunch of helpers. And if we go to the Three.js docs and we look for helpers, you can see there are all these different helpers here. Something like axis helper, grid helper. And let's take a look at how we would use them in Threlte in case you find any other Three.js classes that you want to use, so you can get an idea of how to do that. So we can see at the top here, the grid helper extends the Object3D class. Let's go to our code. We'll import from 3, we'll import the grid helper. And we want to pass it into our scene. And since it extends an Object3D class, Threlte gives us something called Object3D instance. And we use that component. And then for its object property, we're going to pass in our grid helper. And let's just say 100 and 100. And look at that. Now it gives us this grid, and it's much easier to tell that things are moving, that we have some sort of frame of reference, all these units of the grid. Now let's say we had a very specific rotation we wanted. So there's something called an axis helper, and we can import that from 3, follow the exact same workflow as the grid helper because it also extends Object3D. And you can see a little bit in this scene, it might be hard to see right here, that we have some green lines right here. Now, it'd be nice if we could move around, so let's bring in the orbit controls like we did before. If we get rid of our grid helper for a moment, you can see that we have these axis lines here that show us the X, Y, and Z axis. But that's in the middle of our scene, which is where it goes by default, and we can make these lines a little bigger too. And that's helpful for your world space orientation. But if we want it on a mesh, we can just take this Object3D and make it the child of a mesh. And now we can see the rotation on our mesh that we have here. And if we change that Y rotation back to R, you can actually get a better idea. So we are rotating on the Y axis, which is the green line. And so you can see the mesh is spinning along that green line. And if we change that, if we add and say Z axis R as well, it's rotating on both the Y and the Z axis, which is a little wild, so it's kind of hard to tell what it's doing. But the axis helpers can be super helpful in orienting different meshes relative to each other or to the world space. And then the last thing I want to cover is backgrounds. So your canvas by default has a transparent background. So we're just seeing straight through to whatever's behind the canvas, which is really nice if you want to have your scene blend in with the page that you're on. So if we get rid of this background, you can see our shoe sort of looks like it's placed right on the page with everything else. And you could have product descriptions or anything else that you wanted around your model, and it blends in really nicely. But if we want to have a fancier background for whatever reason, you can do that just by styling the div that's behind it. If you wanted to say background salmon, and now we've got a salmon background on both of these. And that's convenient for some cases where you want a quick background or no background or whatever, but you might want to have something a little more interesting on your background that uses some more context from your scene. So let's go to our scene 2, where we have our shoe down here, and say we want to have something that contrasts with green and blue, like a red or an orange kind of background. There are a couple different ways to do that, but my favorite way is to use a mesh and then make it really large and set the material side to be the back side. So you create sort of a bubble around your scene that has the surface material of your background. So let's import a sphere geometry. And then down here, we'll make a background mesh. So we'll just say mesh. So we'll scale it way up. And right now, the color is just the default kind of white color. So we'll say color, what do we say, red or orange? Let's say orange red. And we can't see it. And that's because our material is on the outside of our mesh. And if we zoom out really far, we can see we just have this very large orange-red sphere. So we want to set the background, I'm sorry, we want to set the side of the material to be backside. So down in here, we'll say side, backside. And now we have our background. And one thing that's nice about this is, since we're using a mesh standard material, we actually get a little bit of interaction with the light. Let's just say remove our ambient light. You can see that the background is lit where the directional light is shining, and it's not lit where the directional light is not shining. So that's all for now. I hope this was a good introduction to 3D and Svelte using Threlte, and you're ready to go start creating.
Hello, can everyone hear me?
Yes, I can hear you.
Okay,
Sorry.
awesome.
Forgot I'm the only one in the meeting.
That was great. So I think it really shows how awesome the declarative part is, and just being able to place your components. I really like how you did how the to get the orbit controls, you have to put it inside a camera instead of just having like an orbit camera. You really use well, Threlte really uses the uh, the declarative component APIs to drive the setup of your Three.js.
Yeah, and that was so I think too. Can you still hear me?
Yes.
Okay. So with doing a walkthrough of Vanilla 3, orbit controls are one of the main things where it's easy to see how quickly they can be added to the scene in a declarative way. But I think probably the best example is one that you don't really notice, but it's the screen size responsiveness. So if you resize your screen in Threlte, you don't have to do anything extra. It's just going to adjust the size of your canvas and your scene will update. But to set that up for every single Three.js, if you're doing vanilla Three.js, to set that up every time, it's only like, I think 25 or so lines of code, but it's annoying if you just want to throw something together quickly. To have to do that every single time is kind of tough. And there are a lot more benefits to, I think, the declarative approach that Threlte uses, and like was mentioned, that React 3 Fiber uses. That there's a reason I think people do it, and I think for many developers it makes more sense. I think there was kind of a recent debate on Twitter about imperative versus declarative Three.js, and I think it's probably just a whatever your preference is, and I think a lot of people prefer that declarative style. I, for one, do a lot because I struggled with the Three.js imperative style quite a bit.
Yeah, I especially like it because when you update like a variable, for example, Threlte is handling that for you, and it's re-updating your scene. I did a project recently with Threlte as a joke. It just some text. I used the physics engine to make some text fall onto a platform, and to show the text, I had a variable changing, and Threlte just handled that for me, and it was amazing because my work, I was able to set it up in about 10 minutes, whereas without that, it would have, I don't even know how long it would have taken me.
Yeah, and as they as they grow in complexity too, there's more and more sort of gotchas where you have to remember to update the thing here, update it here, add it to the request animation frame, and so on and so forth. So yeah, I definitely agree with that. It helps a lot to have Threlte take care of that for you. Sorry, I have my video up on the other screen too, and it's distracting me. And I had to resist the urge to use, in the interest of trying to keep the video simple, like for a basic tutorial, to bring in easing functions. I think it's probably the third time I mentioned it now, but to have easing functions available straight out of Svelte that you can use in tween stores for motion, things like elastic in or elastic out can give things bouncy effect. You can even use a spring store to do some spring animations too. And so it's just having that stuff built in is really, really nice. and there's just so many possibilities. I think that's where I kind of got addicted to using Threlte. Was there were just all these little things where I'm like, what if I did a scene where, you know, a bunch of spheres elastic in on mount, and it's like, and then I just make that scene, and then that's like a thing, and then you make another small scene just for every little thing that I wanted to learn, trying to make a scene to do that. And because you can stand projects up so fast, it expedites that learning process.
Yeah, definitely. I I wanted to point out this was just said that yeah, I would have no idea how to do this stuff without the Svelte tools that come with it. And I'm so glad that Threlte exists and is being really well maintained, because it allows people like us to just get started with making 3D stuff, which like a couple months ago, before I touched any of this, I would have been like, that's mental that
Yeah.
it'd be so easy to just drop it in.
Yeah, I think that's why I got so excited and wanted to share it, because I didn't think I could do it after so many times of attempting it. And then finally, just the tooling is so good. You can get started. And it's a lot of fun.
Yeah. If anyone has any questions for Alex, do you want to put them in the YouTube chat and we can see if we can answer them? While we wait for the delay, I think one of the biggest questions I see about Threlte when I bring it up is what's the difference between Threlte and Svelte Cubed or any of the other ones that have existed?
Yeah, good question. And that does come up a lot. There's a GitHub discussion between that someone started about this topic, and so it has comments on it from Rich Harris, the creator of Svelte, and the creator of Svelte Cubed. It has comments on it from the creator of Svelte 3, which I think was one of the early Three.js Svelte integrations. And then it's a discussion on the Threlte repo. So you can check that out, and we can share a link to that too somewhere. So for me, I started with Svelte Cubed earlier this year. I did the vanilla 3, started with Svelte Cubed, and had an amazing time with it. And Threlte is everything you can do in Svelte Cubed. That knowledge transfers nearly one-to-one directly with Threlte. There's some differences in the properties, but what you've learned with Svelte Cubed is the same. It's just that Threlte has way more components that you can use, plus those integrations, plus the built-in out-of-the-box extras that it has, like the float component and some other, and text, and then of course physics as well. And to Brittany's question, is this what Svelte Cubed was supposed to be? Or wanted to be? I don't know how. I guess I defer to Rich on that question, but I imagine yes. And he's said some really nice things about Threlte, which has been great. He kind of endorsed it on Twitter as a good option for Three.js and Svelte, and his comments in the discussion were also very kind. So yeah, I don't want to put words in Rich's mouth, but it seems like this is where Svelte Cubed was going, and Threlte feels like a natural kind of progression of that.
That's awesome. I've seen the tweets, and I'll try and remember to put all that in the description for anyone who's interested.
Yeah, you don't have to put my ramblings in. I'll just send you a couple links to the discussions,
Okay.
and we can go from there.
Okay.
And the docs too. Yeah, in the comments, someone mentioned the docs.
Yeah.
The docs were really well done early on for Threlte, and are updated along with all the new releases and stuff, and so that does help a lot.
The first time I ever tried 3 or any 3D was Svelte Cubed. I took a course on it, and I got to the part where we were loading GLTF models, and I was like, why am I having to write 10 lines of code that's not asynchronous to load this? And then Threlte's just like, have a component that will do it for you. And I was like,
yeah,
This,
Do you
this,
have
this
a
is gonna be great.
Do you have a URL for your GLTF? Just put that here and it'll show up on the screen. And then you can get your interactivity, your scaling, your rotation, all that stuff just right on the component. It's very nice. And there are also more. So, if you have animations or if you want to change the materials or something and break down your GLTF, there are other techniques for loading GLTF in Threlte that might be a little more verbose, but they give you a lot more flexibility, and you can tailor things as you need them. And that's another point I wanted to make, is that Threlte gives you building blocks to make things simple, and then once you kind of get the hang of those and you want to do something more advanced, you then discover that Threlte also has something that will let you do more advanced things. It'll give you access to the renderer or the scene or the camera to make changes that you need to make. Yeah.
That's really awesome. I'm a big fan of low-level APIs with high-level abstractions to make it super easy to do it out of the box. But then if you need that access, you have it without any messing around with hacky things.
Yeah, that's a great way to put it. And someone mentioned in the chat upcoming stuff. So if you're on the Threlte Discord, you can see the discussions about. Yeah, here it is. You can see the discussions about contributions and the roadmap and things that are being actively worked on. And right now there are some big changes to the developer experience for Threlte, and not just the DX, but also the performance and as is being mentioned, the low level stuff is around the corner. So everything that was in the video you just saw, hopefully will still be very valuable. But the way that some of it's implemented will get, I think, simpler and much more powerful and more performant based on first analysis. So if you're interested in the changes that are coming up, check out the Threlte Discord, and you can participate in those conversations and feedback. And it's a great place. Every day I learn something new on the Threlte Discord. It's really, really fun. Even things that aren't Threlte related, I've learned more about, package management and version management in the Discord. So it's a great place to learn.
That's awesome. Does anyone else have any questions? We have to wait for the stream delay. So it's always the bane of streaming, waiting for the delay to end.
Much more powerful changes on the horizon, as is being mentioned in the chat. That's 4 times more powerful.
Was there anything else you wanted to talk about?
Colors. Do I have any tips on colors? I am not a designer. I find colors that in scenes that I like from around both the Threlte community, but also there's the Three.js community in general. Anything that looks cool, I try to figure out why it looks cool and take inspiration from that. Color contrast. If you have a blue, add an orange. If you have a green, add a red. If you have a blues and yellow, anything cold and warm at the same time is a good color contrast. So that's my approach. And colors I spend so much time on because I don't know what I'm doing. And so I'll say, what if it's blue? What if it's pink? What if it's purple? And I'll just keep kind of going through something until it looks a way that I like it, or I can't. I don't have any more time to spend. And the other thing I'll add is the physics integration. If that seems daunting, and Willow, you said you just did it. Once you understand how Threlte works and how it makes look at the physics examples, and it just makes so much sense. And then you try it, and then for me, I wrap my component in this component, and then it's like, oh, and it just works. Like it's very simple to add, and you get kind of addicted to adding physics to everything.
I was blown away by how simple it was. I'd seen I've been in the Discord a while, and I was following the updates, and I saw, oh, they've added physics, and it felt quite daunting. And I went to add it, and it was I think 4 components or something, and I was like, this is really intuitive.
Yeah, it is.
And I couldn't tell you in a million years how it works, but just being able to drop it in was brilliant.
Yeah, and then you can start exploring too, all the properties on these components that they'll work when you first use them. And like you said, they give you these abstractions, and you can start adding properties and just and customize them as much as you want. And it's pretty fun to use.
Definitely.
There are a couple of questions in the chat. Have you used shaders in Threlte? So I'm still working my way through the book of shaders. It's dense, and GLSL I don't understand, but I know you can. I've used a library called Lamina, and that's a pretty easy to use library as well. You just create a class that's from Lamina, and you pass it some different layers for a shader, and then you can drop it in as the material on your mesh or on your geometry. And so that's the kind of the extent to my shader experience. So I don't know. I haven't used anything beyond that. But Lamina is a great tool. I made a tool to make using Lamina even easier because I liked using it so much. There's a lot you can do with it.
So what does for someone who doesn't really know any of what you just said, what does that mean? What's GLSL and Lamina?
Yeah, so shaders are, again, I'm not going to have the by the book definition, but shaders make stuff look really cool. My understanding is they use the GPU to sort of create effects on sort of every like vertex of your material. And again, that's probably a terrible definition, but if you look up shader materials or shaders, you'll get the idea of kind of what they're doing. Anything you see that looks very cool in terms of the material that's on something is probably done with a shader. And there's so much more you can do too that is beyond me. And you can create shaders in a language called GLSL. It's GLSL, right? GLSL.
I think so, yeah.
Yeah. And GLSL is to me, looks very strange. So I haven't really mastered how to write that code yet. But there is a resource called the Book of Shaders, which is a free online book that seems really good so far. I'm only in chapter 1, so I haven't worked that far through it. But it seems like if you want to unlock some very interesting visual effects, shaders are kind of the way you need to go to do that.
Awesome. Someone asks, is Chrome DevTools all you need to troubleshoot, benchmark, etc. for 3D work, or is there other tooling / extensions you recommend?
It's all I use. So yeah, DevTools they have like a frame rate monitor that is a little buried, but I kind of use the frame rate monitor to monitor things, the console to catch bugs, and it helped for a while. I was using my laptop up until recently was a 2012 MacBook Pro. So I was just using a very old laptop as my machine to debug on. And if things didn't work on that, then I had to make them better. So that's all I use. But I'm also curious to see if anyone has anything to share in the chat of what they use to debug stuff. That would be helpful to know.
Is there any more questions? Someone said, not sure if this is a Three.js question or a Threlte question. Can the physics mechanics be imported using Threlte or Unity or both?
So I know Rapier is its own physics engine, and there was a lot of work to integrate that into Threlte. So I think if you wanted to bring in a different physics engine, you would have to do that integration yourself. But I didn't write the Threlte physics integration, so I'm also not great to answer that. So I noticed somebody said the frame rate monitor. Yeah, it's in the renderer. So if you, I forget the exact command, but if you go into DevTools, I think you can Command P for renderer, and then it'll open a tab next to the console, and then there's like a checkbox for show frame rate statistics, I think is what it's called, and it'll pop up on the screen.
They like to hide things, I think. Yeah. I only recently discovered that you can actually take a screenshot of a website using DevTools, and I've been
like a full length one, right? When you do how do you access that again?
It's a command, I think.
Okay.
So like Control P, I think. But like after needing that functionality and having to doing like hacky ways or JavaScript to do it for years and years, and then I'm like, it's been here this entire time.
Yeah,
but,
that's all my DevTools tricks I learn off Twitter. So I hope I hope Twitter can stay around just so I can keep learning all the different things in DevTools.
Definitely. Hopefully they don't uh maybe I think Mastodon is what everyone's using now, right? Maybe you'll have to make a Mastodon for
Yeah.
DevTools hacks.
Yeah, I might have to figure that out. Honestly, I got overwhelmed when I first tried to join. I felt like I was committing to a server and I didn't know anything about it, so I didn't want to commit to anything I couldn't undo. So I just gave up. I'll wait until the sort of the land grab is done and people have all settled on Mastodon before I figure out where to go. I'll be a late adopter.
I've heard about it for a long time, because it's I think it's very popular with Linux users, but I've always been like I've always never known or even bothered to look into what it is until now. It's really interesting how it works.
Yeah, I imagine they're pretty overwhelmed. Feel kind of bad for them. It's a big uptake in users.
Definitely. Well, at least it's decentralized, right? So they're not going to be like, oh no, our server bill's just gone through the roof.
Yeah.
If no one has any more questions, then we'll end it here. It's been really great to learn more about Threlte and to meet you, Alex. So thank you so much for coming on.
Yeah, it was great meeting you as well. Thank you again for setting it up, and thanks everyone for joining and for sharing. And yeah, thank you for coming.
Oh, someone's asked, how do you know or find out what part of the app is running on the GPU, the main JavaScript event loop, or in CPU/WebAssembly?
This is the part where I pretend to have connectivity issues and just drop off the call because I can't answer that question. I don't know how to answer that.
Okay. I'm sure there's probably an answer somewhere, and I'd assume a lot of I'd hope a lot of it's running on the GPU. But who knows? Honestly, I've a friend of mine who was doing a lot with I think it was opacity recently. Recently learned that it's not running on the GPU, and that's why his entire app keeps crashing.
Oh no.
So, yeah, I think at least Chrome historically underutilizes the GPU, but we should be hopefully fine.
Yeah.
Cool.
Again, that's where the 2012 MacBook was helpful because it's an integrated GPU, and if anything too stressful would it'd take off with the fan. So
a little rocket would start in the corner of your room, and you're like, okay.
Yeah, only like 3 infinite loops have ever like fully crashed my Mac, and that was with the old Mac.
I think it's a great metric. I think old MacBook, can it run it?
Yes, exactly. If it's a little laggy on my old MacBook, I'd usually think that was good enough. So
apparently there is a performance tab, which gives you CPU and GPU performance things, which is great. Another DevTools thing I did not know existed.
Yeah, I don't know how to use the performance tab. I've looked at it a bunch of times and tried to kind of get a hold of it, but it's over my head. Maybe this should be the next stream, someone going over DevTools and how to use it.
DevTools 101.
Yes.
Honestly, I feel like that would improve everyone's life immensely if we did that. Because it's sometimes it feels like a black box of all these powerful things that I don't know exist.
Yeah, absolutely.
A Threlte event about DevTools, definitely. Awesome. Well, it was great to meet you. Thank you so much for coming on. And I'm
nice meeting you too.
Excited to see more Threlte development and whatever comes out from that, and hopefully build some more stuff with it. I keep having to try and find excuses to make stuff with 3D, because like most of my job doesn't involve that, and I'm like always searching for a reason to try new things or build with things like Threlte and stuff. So yeah.
Yeah, it's a great tool to use. So yeah, thank you so much. It was really nice to meet you as well.
You too. Awesome.